Alright guys, I hope you have been enjoying these videos. I think it's kind of nice to have an explanation of something that you can come back to, and it's also nice that you can be sitting anywhere in the room and you have a front row seat to something that I might put on the board and talk about. So let's get started with this video. This is about volume. We're going to start working with some math up and coming. And the first thing that we're going to work with is volume. And what is volume? Well, it's the amount of space an object takes up, or just something takes up. It's just the amount of space. What units are used for volume? Well, you might see two things. First off, depending on what we're talking about, you might hear us talk about liters, or in a smaller version, milliliters. That would be used for liquid displacement, and we're going to talk about what that is. The other thing you might hear us talk about when we're measuring volume is meters cubed, and I know, sorry, just put meters 3, or in smaller version, centimeters cubed. Okay, that would be used for like when we're measuring solid objects, like using length times width times height. We might be using the terms meters and centimeters. So how do we measure volume? There are two ways that I want to talk about. The first is liquid displacement, and then the second one is the classic length times width times height. Okay, so this is for liquid displacement. As you can see here, this object that is right over here, this is a graduated cylinder. A graduated cylinder. And let's imagine that this rock over here, this is the object that I want to measure its volume. I could use liquid displacement. And what I would do is I would fill up the graduated cylinder, and I would look at the meniscus. Maybe you've heard of the term meniscus before, but the meniscus of it on a graduated cylinder is where the liquid dips. It's where the liquid dips, and I've highlighted where that would be. You kind of have to get down to eye level to see where it dips, and you always read the bottom of the meniscus to get the most accurate reading. So just to put that in writing for you, most accurate equals reading bottom of meniscus. Cool. So that way you have it in writing. You can also just take liquid displacement without dropping a solid in. So if you're going to try to measure the volume of a solid, and sometimes we do that when the solid is irregular sized like a rock, we would fill up the graduated cylinder and we would take that initial volume, whatever it is, by reading the bottom of the meniscus. It's probably going to be in milliliters. So like this one looks like it's about 90 milliliters in the picture. And then if I were to drop the rock in, however much it moves up, that would be the volume of that rock. So let's say the initial volume may be 90. Up at the top I see about 90 centimeters. And then I drop in the rock, it moves up, I don't know, let's just say it goes to 100 centimeters. So my final volume would be 10 centimeters. Okay, that would be the volume of the rock in liquid displacement. You could also do that with just measuring the volume of the liquid without dropping in an object. For example, the volume of the liquid in the graduated cylinder right now is 90 centimeters. And so that is how we would record for a liquid. This is probably the classic one you have heard of in math class. If you have an object that has a set size and a set structure, such as a square or a box, you can easily measure it using the formula volume equals length times width times height. And we do that using a ruler. Now in science we always talk about centimeters and meters. We are going to talk about centimeters. And what you would do is you always start at the 0. Okay, so when you're measuring volume to get the length times the width times the height, you always start at the 0. Sometimes the 0 is marked. Sometimes it's just the end of the ruler, so you have to decide. And then you just hold the ruler up to the object, and wherever that lands, so like if it lands on 2, right here you can see there's 2 centimeters, it's pointing to it. And let's imagine that our object comes to that arrow that the millimeters is pointing to. So that would be 2.1234. So that measurement on the ruler right now is 2.4 centimeters. Okay? That is how we would measure on a metric ruler. And then we would just plug that in. So like if that was our length, we would just plug in 2.4 centimeters to our length, whatever our width was, times whatever our height is. And we just multiply those 3 numbers together. And that is how we would figure out our volume. The catch with measuring volume like this is volume, it would always be in either meters cubed or centimeters cubed. In this case, since we're measuring with a centimeter ruler, it would be centimeters cubed. So just remember that. You always have to cube your answer, and that's because you're taking 3 numbers and multiplying. You're taking 2.4 centimeters times whatever, 3 centimeters times 4 centimeters. And so since you're taking centimeters times centimeters times centimeters, you have to write centimeters cubed. All right, that's the end of my explanation for volume. We are going to have some practice in the lab. So I'll be walking around just to make sure that you guys understand exactly how to measure volume. Remember, you have 2 choices. If it's an irregular object, you can measure it with liquid displacement. That tends to not be as accurate as a measurement, but it would be good enough. If you have the option to do length times width times height, that would be the more accurate option. So if you have an object that you definitely can take the volume in that way, please do that. All right, good luck.